Hi guys, this is Miss Goki, and today we are working on Lesson 4, Solving a Linear Equation. Our student outcomes are students extend the use of the properties of equalities to solve linear equations having rational coefficients. So to solve an equation means to find all the numbers x if they exist so that the given equation is true. In some cases, some simple guesswork can lead us to a solution. So let's look at this equation, 4x plus 1 equals 13. Take a moment, pause your video, and try to figure out if you can guess a number that could go in for x to make it true on both sides. So if we look at this equation, 4x plus 1 equals 13, you could probably guess that if we set x equal to 3, this makes the equation true on both sides. So then we get 13 on the left-hand side and 13 on the right-hand side. But what if I gave you an equation like 3 times 4x minus 9 plus 10 equals 15x plus 2 plus 7x. As you can see in this equation, we have a distributive property here. We also have more than one variable. We have one on each side of the equation, and we have to combine like terms. So this is kind of what we're going to start off with in this lesson, which if you look at these rules, this is kind of what they're telling you. We have the distributive property, which you guys used last year, same with combining like terms. So we're just working on having variables on both sides and figuring out how to eliminate them. Let's look at example 1. Solve the linear equation 2x minus 3 equals 4x for the number x. So first we're going to use a tape diagram, or other known as bar modeling. So on the left hand side we have 2x minus 3. So we're going to draw our bars. We have x and x, and these are the same length because they're the same value. And then we have our negative 3. Now on the other side of the equal signs, we have a 4x. So because the left-hand side and the right-hand side are equal, we need to make sure that both our bars are equal and that they're the same length. So when we split that up into 4 x's, we need to make sure that they're all the same size as the x's that we had up above, and that they're the same size as each other here. So now, because we know that these two bars are the same length and they're the same size, we can simply cross out one x from each because we know they have to be the same length and the same size. So then we can also cross out these two, because once again these two bars are equal and these two x's are equal to the same length as these two x's. So as you can see, all we are left with is two x's in one tape diagram, and we're left with just the term negative 3 in the other one. So now we can just take this and write this as an equation. So we have 2x, and we know this has to be equal to negative 3 because we said that the bar modelings and the tape diagrams, whatever you'd like to call them, are equal. So now we can just finish solving this equation. So we can divide by 2 on both sides to get our x by itself. So when we do that, we are left with x equals negative 3 halves. So now we're going to solve it algebraically to see if we can get the same answer. So if we rewrite the equation 2x minus 3 equals 4x. Now if we look at the equation, you can see that we have x's on the right hand side and we have x's on the left hand side. So we want to pick the smaller x's and get rid of them. So we're going to pick the 2x on the left-hand side over here, and because they are being added here, we want to subtract them. And what we do to the one side, we have to do to the other side, so we will subtract them from both the left and right-hand side. Now these simply just cross out, and all we are left with on the left-hand side is negative 3. We have to bring the equal sign down, and then 4x minus 2x simply just gives us 2x. So now we are almost there. We only have one set of x's and we have one value. So we can simply just get x by itself by dividing by 2. And if we divide by 2 on the right-hand side, we have to divide by 2 on the left-hand side. And then we are left with x equals -3 halves. And as you can see, they both match up. Whether we did it algebraically or we used the bar modeling, we both got an answer of x equals -3 halves. We will try solving a little bit of harder one, but this time we're just going to use, we're just going to solve these equations algebraically instead of using the bar modeling. So we want to solve the linear equation 3/5 x minus 21 equals 15. So we have 3/5 x minus 21 equals 15. Now, unlike the last problem, this problem we only have one x, but we have numbers on both sides of the equal signs. We have the 15 on the right-hand side and the -21 on the left-hand side. So we want to get rid of the smaller number. And because we have -21, that's smaller. So we just want to do the opposite, and we want to add it to both sides. And what you do to one side, you have to do to the other side. So our 21s cancel out, and we're left with 3/5 x equals 36. Now from here, we need to get x alone. So there's a couple ways you can do it, but we are going to multiply by the reciprocal. So the reciprocal of 3/5 is 5/3. And if we do it to the left-hand side, we have to do it to the right-hand side. So then our 3/5 cancel out, and we're left with x on this side. And on the right-hand side, you guys can either plug this into your calculator, or you can do 36 divided by 3, and then times that by 5. But you get 60. Now, we got our x to equal 60, but how do we know this actually works? The easiest way to figure out if this is the answer to the linear equation is we're going to plug it back in. So let's rewrite our equation. And this time we're going to plug in 60 for x. And then when you do out all this algebra, you get 15 on the left-hand side, and you get 15 on the right-hand side. So that way we can tell that the answer we found, x equals 60, actually does work for this equation. And our last example, example 3, we're going to solve the linear equation 2 in parentheses 3x plus 2 parentheses equals 2x minus 1 plus x. And we're going to want to make sure we state the properties that justifies our steps and why we chose it. So let's start by writing out our equation. And as you can see, we do have variables on both sides, and we have more than one set of variables. So looking back at our list of rules, we could do a couple things. We could either use the distributive property on the left-hand side, or we can use combining like terms on the right-hand side. I'm going to start on the left-hand side, and I'm going to use the distributive property. So and when we distribute, we get 2 times 3x, which is 6x, plus 4. And then our right-hand side just stays the same because there's nothing to distribute on that side. So looking at our equation now, we simplified the left-hand side, so now we should simplify the right-hand side. So looking at the right-hand side, we can combine like terms. So that's what CLT means, just an abbreviation. So we have 6x plus 4, because there's nothing to combine on that side. And then we can combine our 2x and our x to give us 3x. And then our minus 1 just stays because we don't have any other just numbers in the equation. So now we're back to, we have everything combined, but we have variables on both sides. So let's get rid of our x's and combine them together. So the easiest way is we have 3x here, and we want to do the opposite operation. So since we're adding here, we want to subtract our 3x on both sides. These cancel out, and on this side, on the left-hand side, we're left with just 3x. We have to bring our plus 4 down, because we didn't do anything to him, equals, and we're left to just -1 on the right-hand side. So now we're almost there. We have all our x's combined. Now we want to combine our numbers. So we can subtract 4 from both sides. When we subtract 4 from the left-hand sides, they cancel out, and we're left with just 3x equals, and then -1 minus 4 would be -5. And then we have 3x equals -5, so we need to get rid of our 3. So we can divide by 3 on both sides, and we are left with x equals -5 thirds. And we can do the same thing with this one that we did the last one. We can plug back in our -5 thirds, our answer, to see if it matches and gets us equal terms on each side of the equation. So if we do 2 times 3x plus 2 equals 2x minus 1 plus x. Now we can plug in our -5 thirds. So we have 2 times 3 times -5 thirds plus 2 equals 2 times -5 thirds minus 1 plus -5 thirds. Now you guys can just plug each side into your calculator, or you can do it out. But you get, on the left-hand side, you get -6 equals -6 on the right-hand side. So that means the x we found, x equals -5 thirds, is the solution to this linear equation. And we'll work more on solving finding solutions for linear equations in the coming lessons.